All right, so we're working on target 2. And this target is, the main question here is, how do I solve an equation? So we are going to be looking at what we call simple equations. And then as you go into 7th and 8th grade, you'll be working on more difficult ones. So this is our learning target. This is our goal. By the end of this target, we should be able to solve an equation with no problems. So what is our goal today? Well, that's pretty simple because it's very similar to our target. How do I solve an equation? That's what we're still doing. We're looking to solve an equation to find the value that makes it true. So in the last couple of weeks, we've been putting numbers in, guessing, checking to see what works, what doesn't work for the variable. This case, I'm going to show you the algebraic way of doing it. And so there are 3 steps. The first thing we always do is we are going to box the variable. That's the first thing. First step. The second step, when we are done boxing the variable, which means getting Miss Olton, putting her in a box, the second thing we do is we isolate Miss Olton, or the variable, by doing the inverse, or what we call the opposite. And there are some specific opposites in math. The opposite of addition is subtraction, and the opposite of subtraction is addition. The same thing for the other 2. The opposite of multiplication is division, and the opposite of division is multiplication. So once we do the opposite, or what we call the inverse, the last thing we're going to do is then work on step number 3, which is we solve for the variable. We figure out what the variable equals. Essentially, we're getting Miss Olton all by herself. And the reason why I say that is because last week, remember when we were working on our algebra tiles, we made Miss Olton our variable. Okay, so here are the 3 steps that we just discussed. On the left-hand side, this is step number 1, number 2, and number 3. And it's very easy to understand what our learning skills are for this week because there's literally the steps to solving an equation. So let's get started. The same thing that we did last week is what we're doing this week, where we draw a wall. So that's the first thing we're going to do for this first equation, is we're going to draw a wall so we can tell the difference between the 2 sides. All right, so the first step says we're going to box the variable. That is step number 1. So let's go ahead and do that. Let's put a box around the variable. Now remember, the variable is a letter that represents a number. So don't forget that. It's a letter. Okay, that's Miss Olton. Now the second thing we want to do is get everybody away from Miss Olton. So we are going to isolate the variable, is what it says, or get Miss Olton all by herself by taking the inverse. So last week, what we ended up doing with our algebra tiles is that we would literally put 16 algebra tiles here. And yes, I'm going to draw 16 so that you can see what it looks like. And then in order to move those 16 algebra tiles over here, we had to do the opposite. So we did the opposite of 16 positive algebra tiles, because you see this right here is positive, this little plus sign, okay? And so we did the opposite. Remember, we dragged 16 negative ones here. So we're going to do that. And then remember, we would cross these out because they would equal 0 now. Okay, we got rid of them. So now we're going to take these and move them over here. So we're literally going to take these and we're going to move our 16 negatives over here. And I'm going to write it right here underneath our number. We are taking 16 negatives. Okay. Up here is 19 positives, so I will go ahead and draw 19 positives. There's 5, 10, 15, 16, 17, 18, 19. And I know they're positives because this 19, it doesn't have a sign in front of it, so therefore I know it's a positive sign. Okay? So remember, the next step is we isolated the variable. We got Miss Olton all by herself, so I could literally just put a negative 16, just like what we did, and we can cross these out. Okay, so we isolated Miss Olton, and now she's all by herself, so I can put Miss Olton down here. And then the last step is we solve for the variable. Okay, so basically we're adding or subtracting, and the way we did this last time was we figured out 0 pairs. I have 16 negatives, so I can cross those out because I'm going to cross out 16 positives. Remember, we made 0 pairs, we dragged them over, so I have 16 negatives, 16 positives, those make 0. So I am left with 3 positives, which I can put down here. Basically, it's the problem 19 take away 16. 19 take away 16. So my final answer, my value that makes this true is 3. Well, let's test it and make sure that it does equal 3. We have 19 on this side, we have j on this side, and plus 16 on this side. So if I put in a number for j, I'm hoping that they're going to equal the same on both sides. That would make it true. And that is correct. 16 plus 3 is 19. So I know for sure that they are balanced, and that is true. So drawing those positives and negatives are fine when you have small numbers, but it's starting to get a little bit more difficult, and I don't feel like doing that. So I'm going to show you now just the algebraic way. We started doing it, but now I'm going to show it to you. Just algebra, no algebra tiles. So I'm going to box Miss Olton. That's learning skill number 1. Step number 1 is box Miss Olton, that variable. The second thing I know is who is with Miss Olton that needs to go away. I have to isolate Miss Olton. I have to get her by herself. So I'm going to look at this -7 right here. And I know I have to move this -7 over away from Miss Olton. So remember, we do the inverse or the opposite. The opposite of 7 negatives is 7 positives. So now I can move those 7 positives over. And remember what we used to do with our algebra tiles. I would literally cross those algebra tiles out. Okay, so on this side I have 31 positives and 7 positives. So there's no 0 pairs. I can literally just add them up. 31 plus 7 gives me 38. And on this side, I still have Miss Olton now all by herself. So this is my final answer, which is 38. Now let's check it. We have h minus 7 equals 31. I can put in a number for h, which is 38. So let's test to see if both sides are the same. This side is 31. And then if I subtract the other side, 38 minus 7 is 31. So I know they're balanced. So it works. Yes, it does make it true. The value does make this whole equation true. Okay, for this last one, I want you to go to our calculator because you have to start getting used to it for our testing that's coming up for the state. Oops. I want you to go to Desmos.com and to use that calculator. Okay, now I can't pull up Desmos.com, but I will be using it also just to practice. So let's do the same thing. Step 1, we box our variable, which means Miss Olton. We box it right there. Step 2, learning skill number 2, is we have to isolate Miss Olton. We have to get her all by herself. So we have to look to see who's bugging her. This person right here is, so we're going to have to move that person over. So we do that by doing the opposite or the inverse. Remember that. So we're going to do the opposite of 1.3 negatives. We're going to do 1.3 positives. So we can move it over here. And remember, we would cross that out once we were done. So now we have Miss Olton all by herself. Miss Olton, M. And on this side, I'm literally going to put into my calculator 2.4 plus 1.3. So 4 plus 3 gives us 7, and 2 plus 1 gives us 3. And then you see those decimals in the middle, we just bring it down to the middle also. So my final answer is 3.7. Well, let's check it to make sure that they're balanced, that the value really does make it true. So our original equation was 2.4 equals m minus 1.3. So remember, we're going to have to put that variable, a number in, a value in for the variable. So I have 2.4 on this side, and on this side I have to test to make sure 3.7 minus 1.3 equals the same thing. So I'm going to put into my calculator 3.7 minus 1.3. And yes, it does equal 2.4. So this side equals 2.4, and this side equals 2.4. So I know for sure they are balanced. And that is it. That is how you solve algebraic equations, simple ones, with algebra instead of algebra tiles.